Welcome to this tutorial slash, I guess, post-mortem on many of the projects that Samim's been working on. So Samim is a researcher, artist, engineer, somewhere in between. He does magic with computers, and one of the projects, or many of the projects he's been doing recently, are neural network based, including text generation. And some of those you might have seen in mainstream news or on Reddit, or it's become a very hot topic, and it's a pleasure to welcome Samim to talk about them today.
Thank you.
So take it away.
Thank you. Right, just going to start briefly, for those of you who don't know me. I'm experimenting mainly somewhere in between game, web, music, and AI. Currently, my affiliations are 2Bits, which is a game company, Unplug, which is a hardware company doing anti-surveillance tech, and AX is my newest venture, which is in the AI space. And the reason I'm here is because for the last couple of months I've been doing, I'm trying to do weekly experiment series on machine learning. Now, it's important to note these experiments, I'm obviously using the experiments to teach myself about deep neural nets and these kinds of techniques. But I'm using them as a thesis of saying design now is designing with input parameters, outputs, and even outcomes. So there's a bit of a thesis developing, and you can find me mainly on Twitter, where I'm a bit hyperactive. So for a moment, I would like for you to just maybe close your eyes, if you like or not, and imagine that I'm President Obama. And I'm going to read you a little text. Good afternoon, God bless you. The United States will step up the cost of a new challenge of the American people that will share the fact that we created the problem. They were attacked, and so they have to say that all the tasks of the final days of war, that I will not be able to get this done. The promise of the man and the woman who were still going to take out the fact that the American people have fought to make sure that they have to be able to protect our parts. It was a chance to stand together, to completely look for the commitment to borrow from the American people. And the fact is, the man and the woman in uniform and the millions of our country with the law system, that we should be a strong sketch. So I'm going to just jump a little bit ahead and end with my favorite bit. Thank you very much. God bless you, and God bless the United States of America. Now, I'm not reading this just because I like Obama, but I'm reading this to you because it's generated by a recurrent neural network. Maybe a quick audience question. Who found this talk somewhat believable? Hands up. That's good. Maybe a second question. Who found it entertaining, at least? All right, that's good. So, as mentioned, the entire text you just heard is completely generated by a recurrent network. Rnns, recurrent neural networks, are a class of neural networks in general, but a specialized one. Specialized in a sense that they're excellent at modeling sequences and temporal behavior. And at the moment there's a bit of a renaissance in RNN technology. They've been around for a while, but now they're really blooming. And you most likely find them state-of-the-art models in speech and handwriting recognition, and it's all over the place right now, which I'll get to in the course of this speech. So back to Obama. The process basically started by writing a web crawl in Python that went out and got pretty much every Obama speech that was ever given. And since he's a public figure, it's quite easy to just grab the entire text dump. Which amounts to 4.3 megabytes of text, which that in itself for me is a beautiful statement of just saying, well, a lot of blah blah, but no, it's 4.3 megabytes of text. From that then, it got fed into an RNN, which calculated on a GPU for about a day, and it generates a model. It's important to note this is a character level model, so it learns from character to character, A, B, D, blah, 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 a statistical model, basically, from which it then can generate unlimited new Obama-like talks. And the talks are, they're not perfect, but they are very much in the vein or in the style that Obama actually uses, as it's completely trained on everything he ever said, which is fun. I mean, one of the kind of themes in my work is what I call computational comedy. And there's a lot of this kind of comedic moments springing up from the texts that come out. And again, it's unlimited Obama speeches, so that's an advantage I have over the very well-paid speechwriters. An advantage the speechwriters have that they get 200K a month or a year. Now, one of the funnest tidbits when I released this was that after about a week, pretty high-level Washington speechwriters actually jumped on it and started to retweet it. And I'm not up to this point quite convinced if they understood that this is a machine writing it, or if they thought it's just an Obama speech popping up. Either way, I was very pleased. The whole, this RNN series, for the most part, I'm using a library called char.rnn, which it's a very interesting library written by a guy called Andrej Karpathy. He formerly was a CS student at Stanford where he did this work. Now, obviously, like pretty much everybody else in this area, he's at DeepMind. And char.rnn is a recurrent neural network for training and sampling character-level language models. So again, it learns from the character up to predict statistically how to generate these texts. And it's open source, extremely important to note, and it's easy to use, which is something in AI libraries that you don't really encounter that often. It's easy to use now to the point after many people have optimized and kind of built infrastructure around it, to the point where I actually had journalists contact me. They wanted to know how they do it themselves, and I was able to boot up a virtual machine for them, train them in basically 20 minutes, and they're generating their own stuff now, which is a beautiful outcome if amateurs and hobbyists are getting into the field. The caveat is it's based on Torch, meaning it's Lua. I'm not a Lua fan, I can say this publicly, hello internet. But it's been ported now to Python, and you pick your poison. One of the most beautiful things that came from char.rnn is it started what I call a pop AI movement, and this is, you could say this is a premiere in a sense. Fractals in the 80s did a similar things, but this is a new thing because it's interactive, people doing it themselves. And this is really a milestone in a sense that you have hobbyists, hundreds of them across the internet, springing up on an AI library and exploring what is possible and generating their own stuff. And I think this is a very important thing to emerge, because having these things widely distributed in a popular fashion, open source and easy, is a strong incentive for researchers to keep publishing openly. There's literally hundreds and hundreds of examples that were generated with char.rnn. I'm going to dig into some of my favorite ones, RNN Bible, RNN Cooking, RNN Music. Let's start with the Bible, because we all love the Bible. Somebody fed the entire Bible, New and Old Testament, to the RNN and started to generate the Bible, then built the Twitter bot, and so I think every couple of hours you get a new generated Bible quote. And they're lovely, the Lord, our God, is the Lord. I'm not particularly religious, but for me it sounds quite authentic, if you ask me. As good as it gets. I'm just waiting for somebody to actually formulate a cult out of this, an RNN cult, but that's another story. Another fun one, which I adore, I've actually tried to do this at home in my kitchen. Somebody fed a lot of cooking data, recipes into RNNs, and now is generating new cooking recipes. This is something that actually, funny enough, IBM then Watson team did a bit later, a bit more sophisticated, but this one is way more fun. I've cooked this, and I do not recommend you do this at home.
Did you eat it?
Yeah, I did. Right, so let's get quickly into the nitty-gritty of RNNs, what this is all about. So in traditional machine learning models, they do really, really well with numerical data, solve problem at this point, basically. They do reasonably or really well now with categorical data, as you can see in the top slide there. It's a fairly solved problem at this point, you get great results. But when it comes to sequential data, so again, like you can see there, the cat sat on the mat, that's really at the forefront right now. And its sequences are somewhat magical because you find them in nature everywhere. A lot of things break down to temporal or sequential patterns. So this is very important as a structure, or capturing this structure you find in nature is an essential thing if you're trying to generate good models. Or even meaning, I put this in quotes there, but yes, meaning can be somewhat captured. And it's important to remember, if you're trying to predict the future, you better remember the past. And I have an early form of Alzheimer's sometimes, I think, so I forget my own name. So probably I should have a RNN on my iPhone remembering me of that. So let's just end this presentation. Here is the mathematical definition. Bye-bye, guys. Have fun. Thank you. It's, it's actually not that long, but notation. So in their simplest form, an RNN is just another vanilla neural network, but the important thing is it has a feedback loop in there. And so, very much like a human would, it reads through the data sequentially. And it converts, then it reads through the data, and it converts every single data point into a vector. And then the process that then happens at every time step, it takes the previous time step information generated, as what it would recognize, and the hidden layer, so the transformations, and it feeds it back into the next step. And so you got this recursion or feedback loop, if you like, that is happening over and over and over time. And this is at the heart of what an RNN really does. A bit more in depth, characters, so if we're talking about character level RNNs, get actually indexed into a matrix. So you can imagine A will be assigned index of 150 and so forth. And so you got this neat little clean vector at the end, which you then can compute with. At time step 0, so when we're just getting started, you just feed it a bunch of random data. And it's, if you test one of these models very early in the training process, it will absolutely generate gibberish. And it's beautiful gibberish. It's blah, 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 blah. And, I'm a big fan of Dadaism, and that is the quintessential computational Dadaism right there. At each next time step then, the entire vector, again, it's the feedback loop that is happening, gets the last step, gets fed into the next step, and you got this beautiful recursion happening. Now, what's important to note, the information, so A, B, C, etc., and the transformation to the hidden layer is both preserved. So at any time you can go backwards, and this is what really makes the learning process possible. And at the end, when you finish training the model, you get a beautiful vector, a model that represents the data you train it on. So in the case of Obama, you get this beautiful, maybe 4 megabytes of text. You get a 300 kilobyte model, which you then can test and generate unlimited content from that. Now, Rnns, this is where it gets a bit tricky. I mean, they've been a long time around. So it was invented in the 80s, perfected to some sense in the 90s, but they never actually broke into industry up to the late 2000s in a sense. And so one of the key problems that the researchers were tackling with is this notion of exploding gradients. So you can imagine if you are this feedback loop that I was describing, and at every time you're doing an error signal through it and then back propagating and trying to get a lower error rate, essentially. But if you have a spike, especially one of these recurrent models, it will absolutely completely destroy your back propagation there, and your gradient is just destroyed. And so this was really, really bugging researchers for the longest time until Jürgen Schmidhuber and others came up with clever methods which, in essence, they boil down to gating. So there's two popular models for gating at the moment, gating recurrent units and long short-term memory. LSTMs are more popular in a sense. And I'm not going to get too much into them, but they're basically gating the gradient at one point and making just quite hardcore decisions of clipping them. What's really important to note, I mean, comparing them to traditional machine learning approaches, firstly, and this is something I every time I learn the hard way, they need GPUs. I mean, you absolutely want to do this on a GPU. If you do this on a CPU, you're going to drink as much coffee as an elephant, and it's not feasible. And the other thing is they will actually, on small data sets, most likely perform equally or worse than other machine learning algorithms. But as soon as you have large quantities of data, they will absolutely outperform any other traditional machine learning method. And finally, going back to char and Rn and the stuff I've been using for Obama, this is a character level language model, so it's quite straightforward. You take the letters H, E, and so forth, LL, you turn them into 1 of K encoding, so you just give them an index basically, and you feed that over time into the Rn. And so you can see in this graphic a little bit of a schematic what's happening actually upstream. Right, let's shift away from the technical part and go to some more fun, because this is what I'm here for. So after Obama, and it really did quite well on the internet, I was thinking quite hard, well, what is the magic that to get good outputs on this, you really need good inputs. That's one of the things when you work designing with these systems, you're designing with input outputs. So I was thinking, what constitutes a good input for such a system? And in a sense, you need a formalistic input. So anything that human culture basically has already formalized for one or the other reason is great, because there's a lot of underlying structure. And so what came to mind is obviously TED. I mean, I have respect for TED, but TED is very formalistic. It has a very clear formula that is not spelled out, but I mean, everybody who's seen TED Talks knows they all look the same, they all feel the same. Benjamin Bratton maybe expressed this the best when he called TED placebo politics for megachurch and megachurch infotainment, which, you know, it's tongue-in-cheek, but it has a certain amount of weight to it. So, same process really. Web crawler crawled every single TED Talk ever given. We're almost up to 2,000 at this point. They're quite lengthy, which makes them beautiful. It's a lot of text, 22 megabytes. We feed that into the RNN. Again, we generate a model. One caveat here is that Obama actually generated far less text in his presidency. He's a quiet man. TED, yeah, it's much more text, so you have to fiddle the system quite a bit differently to get good results at the end. And I decided to actually this time around go a bit full circle and do a computational comedy exercise and an uncanny valley exercise and make a video. So what you're going to see is I took existing TED Talks and superpositioned the new text through a text-to-speech system on top of the TED Talks. And, wonderful. If you could turn up the audio a little bit.
We have to have more self-compassion to experiences the power. In fact, we really believe in the supercomputers, where they make them to think about the standard security. It's a physical thing about data in the human beings. But in the United States,
the inventor of
interesting stuff that we think would be a lot science ones. But in the computer, the great country cannot be complicated.
The laughter is generated by the RNN. So TED actually puts laughter in their text dump, and the RNN learns that pattern, bracket laughter, and he obviously generates it back, and I just put a laughter track wherever it said I should.
But the government will have the policy big governments in the case of the question of human beings. So here we end our democracy. Science was to say that moving to the context. And then our commitment that has been the past the world. This is a computer structure. They can't stand out. The second is a profound context of life. And then a couple of animals are all the things that it's going to be degrading on the same. Or to be able to solve the data in an astronaut of a spider.
So I'm just going to, I did a bunch of them, I'm going to just tease the next one and then we'll move on. But see, she's actually a professor of comedy in a sense, of humor. So very fitting.
World War II in the world. And also is this big designer of solutions to the right legacy in the world. We have the result, but they don't have the part of the approach. They're designing the magic of the painter state. The idea of the correlation is not huge. The reason what we still have to be in between the mental sessions and all the computers of real leaders. So there were a very comparing and design for the sky. We live in the world
Right.
project.
I think I'm going to cut it. You get the picture. So now for the fun. Now for the real fun part, because again, as I noted in the beginning, I think working with machine learning systems as a creative tool, like a painter would with his brush, you're designing with inputs, parameters, output, and outcomes. And I'm designing the outcomes as well, meaning, firstly, there is a cheekily formulated theory, or let's say a law, which I call Summer's law of computational comedy, which is any sufficiently advanced technology will develop comedy. And it's funny, but actually if you think about it a bit deeply, in a sense, comedy should replace the Turing test. It's a much harder problem. I'm not going to dwell too much on this. Secondly, much more beautifully, about an hour after I uploaded this video, the Google copyright algorithm came and told me, well, this is a copyright infringement. This belongs to TED. So that video, every time you play it, you're actually paying TED, which is absolutely beautiful. At least they didn't take it down. And thirdly, just to take a full cycle piss, I sent the video to the participants, so Jürgen Schmidhuber and so forth. They're all lovely people. Jürgen Schmidhuber, thank you, Samim, for your computational comedy. Viele Grüße, Jürgen. Sophie Scott, it's a very clever idea. And then obviously the whole machine learning community went nuts. Jan LeCun, the head of Facebook AI, absolutely loved it, posted it twice. And Morozov, which is a social critic I'm very much fond of as well. So very pleasing results for me and very, very funny. And I think Mr. Bean here really, really nails it. Right, let's go back into technical land a bit. So the tricky bit, you can get quick results with Rnns, but not good results. You really need to tune these systems. And the main problem you're going to encounter is overfitting and underfitting. So you really have to adjust the parameters to the size of your data and to the structure of your data, which basically boils down, at least from my perspective, test. And it goes back to what I said earlier, use a GPU because you're not going to iterate very quickly on this stuff if you're not. So in my case, which is something really fun to do, I usually boot up a couple of AWS GPU instances, spot instances. Costs you, 20 cents an hour, absolutely doable, 8-core GPU. You do 10 of those and run different models. At the end of the day, you pay $80 and you're moving really quick. So this is something to keep in mind with all this machine learning stuff anyway. Hardware is dropping crazy right now. And obviously NVIDIA and people like that now have machine learning way up the priority list. So we're going to see a 10x, 20x improvement in the next couple of years. Another fun bit, which I really recommend doing with any machine learning algorithm, dimensionality reduction, so looking at what's happening under the hood. So what you're seeing here is an algorithm called TSNE, which you can imagine when you train an RNN, the vector space this information lives in is extremely high dimensional. But if you're trying to put it on a two-dimensional flat thing like a screen, you want to collapse it down. And so TSNE does that for you, and then you get these beautiful little clusters you can zoom in, which represents what the RNN learned. So you can see punctuation gets grouped into one area, quantity of time, qualifiers, and so forth. And this is a fairly small sample here. These things are absolutely giant, so you can generate, 10,000 by 10,000 big pictures and then zoom in and have a look at what's going on. Very fascinating technique. I've used this for images a lot as well, even more fascinating, but it works fairly well for text. It's fun to do, and it helps you actually evaluate how well your model is performing. Right, shifting gear. So after TED, as that one went really pop culture, so it kind of unintentionally got picked up by everybody from Wire to newspapers. I got a bit sick of that boulevardesque new media coverage because journalists are, they're basically RNNs with heads. So I said, okay, let's do something absolutely obscure that is near to my heart, which is Zen. And Zen is an absolutely beautiful concept because the Zen tradition itself, I'm quoting Wikipedia, enlightenment of the Buddha came not through conceptualization, but rather through direct insight. But direct insight has to be supported by the study of understanding teachings and texts. So it's a total negation there. And Zen says, well, you should read the text, but it's completely useless. So it's perfect for an RNN. So again, learning Zen, write a web crawler, get all the Zen texts you can. The problem here is the West, in a sense, has absolutely destroyed Zen culture because all you find is shitty, really shitty translations and interpretations by Western people who have never meditated in their life or practiced Zen. Doesn't matter. So I filtered that out algorithmically, which is a whole project of its own. Then again, did the model, ran it through the RNN, got a model back. The post which I released the results with actually is more about computational theory of meditation, because I'm absolutely sick of seeing meditation being in this ghetto of esoteric bullshit, even though that's just a linguistic problem. So I attempted to kind of reformulate that in machine learning speak, which meditation really boils down to using selective attention to tune the hyperparameters of a neural network, aim at optimizing its cost function. Voila, there you go. So if anybody of you meditates, the next time I can say this in plain English, if you meditate, you're basically just optimizing your internal neural network. It boils down to that, so I highly recommend it. So here we go. This is the same thing as with TED, this time around with Zen, which I find more pleasing. The media doesn't, which is great. If we could get audio.
The monk asked, I am it. It is a bowl. The Sviwing Taitan. When he was counting to extract the other will be all things. Is the whole of the spare? Go to the root, with the world. The world is not the river. The prince of the soul is a great being who had forgotten the world. What is the state? He clapped with his hands and said, I have realized the earth is the same, I am a complete, the purpose of the I is life, and do not know that if you stop him meditating it, you are not my head or the hat of the wise. He could not be like the emperor to be same that all men are. The traps of the words. When I did not measure the monkey, when the words of the wise men follow into eternity, the sprocket the same life, the ocean of the same fire, or what about the existence of a single? They came to the summoned and said, yes, I am it, the I, something about the monks. Yet the spirit is not displayed. The monk said, when I replied to the state of being, if you come from it, I have nothing to be. The wise who could not respect, you will be do not state. He is nothing, enter. And the other who was in the sea of the things. We speak of a frog state. This is no measure. To use rakes.
Right,
A monk asked,
this goes on infinite, literally infinite, because it just generates as much as you like, which is brilliant. And so I showed this, I sometimes have a friend who's a Zen master, Japanese guy in Berlin, and I showed this to him just to take the piss, and he absolutely approved. He said, that's brilliant, that gets straight to the heart of what Zen is about. He's a man of great, great humor, you must know. So, Zen obviously is a tricky one because this is not going deep enough. So after these results came in, I said, okay, let's take it to the next level. So what is a recurrent neural network? You take the model file that the other recurrent network generate, just feed it back into a recurrent network. You get a RNN. And obviously the outputs are absolutely gibberish, which I'm not going to show you here. Just to further take the piss, I did the null RNN, which basically you take a text file of 100 megabytes with just dots, and you feed it into the RNN. It will train for a very long time. So the computer, you can in a sense say meditate, it's 36 hours. And the results are beautiful, it's just dots. So I recommend anybody with a bit of too much money doing that as well. And then the best at the last, I posted ZenRNN on Reddit, because we all know how nice Reddit is, on the Zen Reddit, which is full of, you would think, full of very contemplative, beautiful souls. It took them about 5.5 minutes. The thread was 150 long in the end, and they had a bloody cat fight. And one of the best quotes, I'm going to read you this. What is more absurd, a person saying machines don't have Buddha nature, or a person saying machines can be gods? I tweeted that on the comedy, because, it's just Zen people, they're, yeah, whatever. Right, so what is this all about, the Zen thing? Just to contextualize it for you. And Claude Shannon really, really helps us here, which this is pretty much my favorite art piece ever. And obviously Claude Shannon, the father of information theory and so forth, we wouldn't be here without him in this technological world. And this is, one of his prime artistic outputs. And I think it really encapsulates the beauty of such experiments. Good. I'm going to shift gear a bit about the greater community because it's quite fascinating what's been happening. And then, this is a bit taking the piss, but yeah, input hidden comedy, thank you. There's a lot, there's hundreds of examples, but I'll show you some of my favorites as we're focusing on text generation. The Jay-Z one is on, they took all the Jay-Z hip-hop lyrics, piped it for an RNN and generate new Jay-Z. Unfortunately, it's just on SoundCloud. Since I can't open a browser here, we're going to leave that one out. But let's take an interesting one. RNNs can generate source code. So theoretically speaking, they're Turing complete. Meaning this stuff actually, theoretically, not right now, but theoretically this stuff actually is executable. And it's fascinating. So this was trained on the entire Linux source code, ran for a very long time, and then it generates code which it looks on the surface of it quite good. There's a lot of research going into this, and there is people now generating executable stuff with RNNs, which is not surprising because yes, they're Turing complete. An experiment I did and it absolutely failed was I got a dump of a couple of thousand of DOS viruses. And I ran those through, and my intention was to generate new computer viruses. Yeah, well, I mean, what are you going to do? The problem there is, so I did then, you have to test them out, that's the main caveat problem. So I did write a script that would actually boot up a DOS machine for each and every virus, test it. Just took too long, I gave up on it. But, here's another one. Somebody ran Craigslist's comments for it. These are 100% accurate. Yeah, fun stuff. And now we're going to what the big boys are doing a little bit with the RNNs. This is from Google, the new results, came out a month ago. So what Google is attempting is they're doing a deep Q&A, what they call a deep Q&A model with RNNs. And you can imagine they're going a step further and they're training an RNN on pairs. And you get this Q&A or chat machine in a sense, and it's scarily good. This then got some media exposure because it has some quite tricky things for Google to publish. But it's a fun thing to look into, and this, in a matter of a couple of years, will actually be a threat to call centers and the likes in a big way. And finally, as I mentioned, I helped a couple of journalists work with that because I think in especially machine learning, we have an educational duty. And so if we can actually take the smart journalists and help them to do their own work and explain to the greater public what's going on the hood, that's great. So she's from Fusion, which is a partner of Wired. She decided to generate erotica, which I'm going to play for you now.
And he's from my legs, so I felt himself in his arms as he shot his cock. I was still hard and moved to the barestical shower. I love you before your mouth. I like that. You should be with my face. You wanted to stop you with a woman. But I was in my love in the mirror. She smiled and said, boy, I was going to be open. She put my head and took my mouth. I was warm and he growled on his face, and then said...
Right, sorry, now it gets X-rated. I'm so sorry. I'm not a pervert. Right, another fun thing which you can do with RNNs, it's really fun actually, you can generate handwriting. So you train an RNN basically on, the caveat is you train it on actual data which is point by point when somebody writes. And then from there, you can go and generate unlimited handwriting. So a thing I've been experimenting with is combining handwriting. So you take Albert Einstein and Adolf Hitler's handwriting, you do it, vectorize it, you put it for an RNN, you get Albert Hitler's handwriting or something like that. And so you can, do fun stuff like write ransom letters and, pick your poison. It's the creative canvas here is big. So as it is a game AI focus a bit at this conference, I wanted to elaborate a bit for a moment on what RNNs could mean for game dev. I've worked in games and I've written text for games, and it's a very, let's call it a manually annoying process. And to write good text, which doesn't happen that often, unfortunately, you need heavy manpower. It's really expensive to get good writers. And then the writers, obviously what I call dynamics, have to interact with design and game design and so forth, which they talk in such different languages, these people, that you often get, yeah, absolutely, you know, all your base belong to us. We're beyond this, but not that much. In some games very much, in some not. And I do see a big opportunity for generative systems, Rnns particularly, to help us out. Because if you very much, let's say, curate the inputs and the outputs with systems, you can generate much more interesting things than I did on the quick with the examples I showed you. Obviously, usage scenarios, you can imagine NPC chatter. Very simple scenario. If you have a kind of an NPC that is not that important, you want to have just unlimited dynamic chatter from that. Use an RNN. It's simple. It makes more sense and fun than traditional approaches, and it's player adaptive, which is very important. So you can seed the model, saying, well, talk angry, talk friendly, talk about this, blah blah blah. So it's on-the-fly customization. This is very powerful. Further, since this is all about modeling sequential or temporal data, you could probably apply it to stuff like fighting games where you have very clear temporal patterns. You know, if you have, I don't know, what's a fighting game? You see, I don't play these games. But you can...
Killer Instinct.
Yeah, there you go, there you go. And you know, model that with an RNN and actually use it as an AI. That's something that is to be explored. Then models are really reusable. This is something great with all this stuff, so you can plop it into multiple games and tweak them or seed them differently. And finally, you could probably do distributed learning, so actually take text input from users, distribute it all over the games that they have installed in the local machines, feed it back on your server and generate new models on that, and your next game will have a 10x better model there. Right, let's have a quick outlook at where we're going in the future. This is Jeff Hinton, one of the kind of pioneers in deep learning. I call him El Hinton now, much better name for him. He works at Google now. There's a lot, and I mean a lot, happening in the RNN space at the moment. Facebook just released a couple of months ago what they call mem-RNN. It's an interesting concept because RNN is all about memory. And current models, yeah, we have gating in there, so we can start to kind of capture more of the underlying patterns. What mem-RNN is proposing is actually using external memory in a sense. They're using a bunch of very nifty techniques, and so you can imagine once that problem is cracked, you can capture unlimited or very, very large sequences. Right now we're in smaller sequences, but if you can capture the sequence of an entire book or an entire library, you will get dramatically different results. So external memory is there. Embedding semantics is a big drive in research. So you're not just embedding text, but you're actually embedding semantic meaning in there. So you can take DBpedia or stuff like that and enrich the text before you train a model, which then yields the benefit on the other end that you can actually semantically query a model. Which is an absolutely fascinating idea. And then finally, something I've learned the hard way is if you have a generative model that generates unlimited potentially content, how are you going to select the outputs? It's a big problem. There needs to be a quality control mechanism. I've, for the large part, done it manually with a bit of analysis tools like I showed you, TSNE and stuff like that. But ultimately, where you want to go is reinforcement learning, which is why it's so important, where you actually have a deep Q-learner, deep reinforcement learner on top of an RNN that then analyzes the outputs and cross-references it, gets a reward signal, and then makes a decision on which outputs to use on that. There's a lot of research going there. And why I put Hinton there, what he's working on at Google at the moment is, as always, they're utopianists. They're working on AGI, general intelligence and reasoning. I'm going to put the presentation online. If you click on that link, there is a new presentation by him where he proclaims, basically, if you read it clearly, that logic as such is going to be cracked by this in a matter of years. Make your own thoughts on that. I just decided to draw my moustache. Conclusion, what is this all about? It's a really powerful technique, RNNs, and it's moving fast. So it's a really good time. It's quite easy to use and get started. It's no black magic. The community is there, so you can get help and feedback and so forth really quickly. I went a step further. I set up a virtual machine for RNN. So it's a 2-click process, I promise. You click, start, you paste in text, and that's it. And you train your model, which is very nice. As well, what I've been doing, and I've been pushing all other researchers to do as well, is I publish all models online on Github, open. And this is very important for anybody in machine learning to be aware of this and push this in the academic tradition. If you look at Google as an example, they do publish papers, and they do publish great papers, but they never publish models, hardly ever. And with Rnns maybe, it's easy to train them, it takes you a couple of days. With image recognition, it takes you months. And so you really want these open models. So this is something to keep in mind, and a small contribution I can do is just publish models. That's one thing. Right, so finally, I would like to note that all the stuff you've seen, Alex asked me to talk about text generation exclusively. It's just a small part of what I've been doing in machine learning lately. Again, it's a creative canvas. I would just like to highlight 2 experiments, and there's many more. One is called Sensual Machines. The other one is around Deep Dream. Sensual Machines, in a nutshell, is an image recognition experiment. And the premise was I wrote a web crawler that went out and got 10 or something like that gigabytes of random images from the web. And I did a TSNE analysis on that. And the web is a nasty place. I was very surprised that a large proportion of that turned out to be adult content. So I was faced with a really difficult choice. Throw away the whole training set there, or data set, or do something with it. And since I'm doing these things on a weekly basis, I need deadlines, I said, okay, let's run with this. And so I ran semi-pornographic material through a bunch of machine learning algorithms, processed this stuff, and saw what is coming out on the other end. So you can do nifty stuff. You can do face detection, obviously, it's quite easy. You can do age detection. You can tag the stuff automatically, so it will tell you, that people, adult, portrait, one woman, indoor, sitting, and blah, blah, blah. Luckily, there was some militaristic footage there as well. So drones, this is terrorist, this is all video, by the way. People, group, action, adult, men. And funny enough, that video, if you look at it, it's a drone killing a bunch of terrorists. As soon as the drone shoots them down, the image recognition model breaks down, and the little blue circle goes away. So that one, on the other side, went further. I trained a deep neural net image recognition model. This is before Deep Dream, by the way. This is a couple of weeks before Deep Dream, to recognize porn, and then you can probe the deep neural net and see what it actually imagines inside. And you get this beautiful, semi-artistic looking pornographic images. And weirdly enough, on Twitter, this thing went absolutely berserk, and media jumped on it, and many people called me a pervert. Imagine, look at these pictures. That's absolutely unheard of. Anyway, and finally, just recently, Deep Dream, obviously, I released the Deep Dream Animator. I think Deep Dream is a very big deal. We can criticize puppy slugs all day, but generative image recognition on this level is unseen and very fascinating. Deep Dream Animator, you can go on GitHub and get it. It's animation software for Deep Dream that gives you stable dreams across frames, which is one of the big problems there. It does nifty tricks like optical flow. You can do guided dreaming, so you can do fun tricks like I just did Charlie Chaplin the other day. You can say, oh, here's a video of Charlie Chaplin, please turn him into a broccoli. And you got this broccoli Chaplin walking down the aisle. Fun stuff, more on the pop side of things, but obviously it has, if you look at Deep Dream, maybe 4 or 5 years out, what we're talking about is language-to-image models. So you type in, draw me 6 dogs sitting in a room smoking a cigar, or you draw a stick figure thereof, and it will generate an image for you, which has absolutely giant implications for all kinds of industries and applications. And finally, to test my Deep Dream Animator, I did the first HD music video in Deep Dream, which unfortunately I can't play because I don't have a web browser here, but yeah, so you can have a look at that online. And I leave you with this, which is comedic but very true. Computational comedy is right in between a beautiful kind of space. And I highly recommend anybody who has a bit of spare time and wants to learn about deep learning and similar methods, go down the computational comedy route. It's much more fun, the results are better, and you'll learn a ton. Cheers.